Here's an update on my battery setup. There goes the fan shutting off on the inverter. And that inverter, let me move this out of the way. That's a GoPower inverter. It's 1500 watts pure sine wave. And it draws about 25 watts in idle current. Or actually, it's never completely idle, but it draws 25 watts approximately in just current that it uses, aside from the load that I've got on it. And I have it connected 24 hours a day to my network and telephone system, which draws about 16 watts, 15 to 16 watts, continuously 24 hours a day. And so the system as it is, if I don't plug anything else into it besides that, it uses about 40 watts continuous, 24 hours a day, and averaged out. Of course, that fan that cycles on and off uses some of that power during the day, because the fan is controlled by the temperature, and it gets pretty warm, because this is not an air-conditioned area, so it gets way over 100 degrees in here during the day in the summertime, as it is now. It's only about 10 o'clock in the morning right now. And so this is 4 L16s connected in series parallel for 12 volts. And I've made another video showing this when I installed the new battery setup. And right over here I have what I had in here before, which is a pair of T105s, golf cart batteries. And they still work fine, but those are the batteries I use for the camper. And they're really not big enough for this setup, cycling every day. And I guess it's been, this battery bank has been in operation a couple of months, I guess. And as you can see, now this is my charge controller, Rich Solar MPPT 40 amp solar charge controller, and it's showing 13.1 volts on the battery bank right now. So that means it's charging, even though it's only 10 a.m. and it's cloudy today. And yet 13.1 volts means that the bank is fully charged. Let's take a look at the water. You have to check this once in a while. Okay, it's full. I'll check a couple of them. Yeah. All good. Yeah, you have to check that once in a while. And I have a gallon jug of distilled water over here. Actually, it's rainwater from my rainwater catchment system. And so rainwater works too. Rainwater or distilled water from the grocery store or wherever. It just needs to not have any minerals in it. Alright. So that's working, as you can see, being that it's got 13.1 volts at 10 a.m. on a cloudy day. That tells you that it's keeping up with the load of 40 watts continuous. And I thought about buying a new inverter that has a lower amp draw, but this is doing okay, so I'm going to leave it alone for right now. And I wanted to make some comments about lithium batteries. Lithium batteries are heavily hyped, and I could name some other YouTube channels that are hyping them, but I don't want to do that. I will say that they're deceptive. You know, they claim that that lead acid battery manufacturers and sellers are engaging in deceptive practices. That's not true. But what they are is engaging in deceptive practices. And an example, I'm not going to mention any names, but one guy who has a YouTube channel and sells lithium batteries. He has a website that he sells lithium batteries on, and he's pushing his lithium batteries that he has for sale, and he lists a price that, you know, a common thing that they say is that lithium iron phosphate batteries are way cheaper than lead acid batteries, even though you can look and see that that's not even close to the truth. But then they go through all this convoluted reasoning to try to prove that what they're saying is true. So this one guy, like I said, he's pushing some lithiums that he's selling, and he claims that they're way cheaper than lead acid. So what he's selling are used lithium cells, packs of used lithium cells, or not even a pack. It's I think he's selling individual cells and some holders for them so you can make a pack, and he claims that it's cheaper than lead acid. But the problem is he does not account for some of the stuff that you've got to buy to make it work, like the BMS, for example. With lithiums, you got to use a BMS, and that's an added price. And of course he sells that too, but he doesn't, you know, when he says that it's cheaper than lead acid, he doesn't include the price of all the things you've got to buy to make it work. Whereas with lead acid batteries, okay, I had to buy some cables. You have to buy that with anything. But that's it. With lead acid batteries, man, you just connect them and go. You don't have to worry about a BMS and all that kind of stuff. So anyway, he's selling these used lithium cells for about the same price as, or maybe slightly less. And another thing they do now is they'll, when they say that lithium iron phosphates have now gotten to where they're way cheaper than lead acid, they will, a lot of times they'll be talking about used cells, and pretty much all the time they'll be talking about the most expensive sealed AGM lead acid batteries they can find. They don't talk about good flooded lead acid batteries that are designed for this purpose, like these. And they're, you know, this is a Trojan Motive series. Now these are not the best batteries that Trojan makes. These are Motive L16s, and Motive means they're designed for machines like electric cranes, floor sweepers, and so on. In fact, L16s were originally designed for floor sweepers. And These things are designed to be discharged heavily every day, and they make some solar industrial cells that are way better than these, that will go for up to 12,000 cycles. And that 12,000 cycles is if you're cycling them in the upper 80% of capacity, but even at 40 or 50%, they still go thousands of cycles. So they're great batteries. They're more expensive than these, but they're really, you know, for the capacity, they compare favorably with the price of lithium iron phosphate batteries. So I would really like to have a set of those. And in order to keep the cycle rate as low as possible, I'd like to have twice as many as I have of these. But this is the best in terms of cash outlay expenditure versus capacity and cycle life and everything. This is a really good setup. And back to lithiums, though. Another thing that and somebody actually took me to task and said, in trying to prove that lithium iron phosphate batteries are cheaper than lead acid batteries, he laid out exactly what he was talking about, which is he chose a $600 sealed AGM battery that was 200 amp hours, 12 volts, 200 amp hours. And man, that's an expensive lead acid battery. And AGM's really, and AGM doesn't last as long as a good, true deep cycle flooded cell battery, as long as you maintain that flooded lead acid battery. Keep it at a high state of charge, and check the water once in a while and top it off as needed. So as long as you do that, these are great. So, you know, when I talk about lead acid batteries, I'm not talking about AGMs, I'm talking about these. So, but this guy picked and chose the most expensive AGM cells he could find, and for his to support his contention that lithium iron phosphate is cheaper, he chose some used lithium iron phosphate cells that were being sold by the same company that sold me those lithium packs I made a video of a while back, and I told you exactly what they said in their ad copy, that these were all good batteries and good cells and everything. They would be wonderful and last a long time, and they were all good. And I bought 5 of them, and 1 of the 5 was good. I contacted them, and they sent me 4 replacements, because I bought 5 packs and 4 of them were bad. So they sent me 4 replacements, and out of those, 2 were good. The other 2 were bad. So I paid for 5, received 3 after some hassle. Initially only received 1 for my 5. But I'm supposed to believe that that they're going to sell me some used lithium iron phosphate cells, and they're all going to be good, and it's wonderful because these used cells cost less than, or slightly less than the most expensive AGM cell this guy could hand choose. No, I don't think so. Of course, he also did not consider the BMS that I would have to buy to make it work, and so on. So anyway, not going to go along with that. And one thing I would be really remiss if I didn't mention, and I've been thinking about, pointing this out for a while, but again, I'm not going to mention any names, but I think all of you will probably know who I'm talking about. There's a guy who put a video on YouTube, and it was heavily promoted. It showed up in, I think, everybody's feed who has any interest in battery systems, where this guy was claiming, he claims, first of all, to be an engineer, and he says, okay, we're going to prove that lead acid battery manufacturers engage in deceptive marketing. And so I'm going to do this this really fair and scientific comparison to prove that lithium iron phosphate batteries are better and cheaper. And so first of all, he chose a couple of 2 or 3 different lead acid batteries. He chose some expensive AGM batteries. He chose one flooded cell battery, which was not a true deep cycle battery and was the cheapest flooded cell battery he could find. And then he used some really deceptive practices to show that, to try to prove that lead acid batteries are not as good as lithium iron phosphates. And he used practices that he basically assumes that the viewer knows nothing whatsoever about lead acid batteries. Or he proved that he knows nothing whatsoever about lead acid batteries. Let's be realistic here. He might have not been completely lying. I think he was, personally. But he might not have been. He might be an engineer who is clueless about lead acid batteries. But it doesn't seem that way from the way he was testing them and then the statements he made. All you got to do is read anything about lead acid batteries and you'll know that his test was not a fair test. Specifically, he put enough of a load. He read that, he heard the hype that you cannot discharge a lead acid battery below 50%. That's not true, by the way. You can. It doesn't damage it. It reduces its cycle life, and so you don't want to do it every day. But you can occasionally draw it down to, say, 20% or so. And by the way, they claim that the lithium, people who push lithium batteries claim that you can use 100% of the capacity every day in every cycle for thousands of cycles. That's a blatant lie, because you don't have to read very much about lithium cells to know that you don't need to fully charge it all the time, because that reduces the cycle life. You need to, it's best to only charge it to about 80% full, and it's best to not discharge it below 20%. But still, they'll say all the time that you can use 100% of the capacity every day, every cycle, and it'll last for thousands of cycles. Not true. But anyway, so what this guy, and they take it as just, an absolute truism that if you discharge a lead acid battery below 50%, boom, you're going to have to buy another lead acid battery replacement. That's not true. But he looks at it and he says, okay, 50% charge is 12.3 volts. So, or it might have been 12.2. I think it was 12.3. But anyway, whatever it was, it doesn't matter. What this so-called engineer did was he put a heavy enough load on it to make it drop to 12.3 volts under load in 20 minutes or something like that. And he said, there you go, that proves that it doesn't even meet published specs when it's new. anyone who knows anything about lead acid batteries knows that these voltages that are listed are resting voltages. It means that it's been sitting there neither discharging nor charging for at least about an hour for those voltages to mean anything. If it drops to 12.3 volts under load, that doesn't tell you anything. But that's what he was doing, and that's extremely deceptive. And I'd also like to point out that these so-called tests this guy was doing, here comes the fan again, these so-called scientific tests this guy was doing he did that at the facility of a major seller of lithium batteries, and it was paid for by that major seller of lithium batteries. So there you go. You know, even if we're gullible enough to believe that's not slanted, still, you know, just looking at the way he tested the lead acid batteries and declared that they don't meet spec, that's entirely deceptive, and anybody who knows anything about lead acid batteries can see that. Okay, having said all that, enough with the negativity, man. The positive is that this is working, and it's now at 13.2, so it's still cloudy outside, I can see, and even on a cloudy day it is charging, and it is fully charged at 13.2, because resting would be, if it were at rest being neither discharged nor charged, it would be at 12.7 or 12.8, and it's showing 13.2. Let's take a look. (38°C). No amperes into the load from this because I have no load connected to it. 14 amperes so far into the batteries today. 13.2 volts. 6.8 amps into the batteries right now. 50.2 volts on the solar panels, which I have 300 watts of panels, 3 100-watt panels in series, and I've got 2 more that I'm going to put, at least one more up there, maybe 2 more. 2 more will be kind of pushing it a little bit, because this is only good for a maximum of 100 volts in, so I might just put 1 more, and then perhaps eventually put in a parallel set of another 4. But it's working fine right now as it is. I do want to put at least 1 more panel up there to have a little bit of overhead, so that I can plug something else inside if I need to, and it'll still bring it back up to full every day. And about the lithium iron phosphate, though, I was looking this morning at the 100 ampere 12 volt Battleborn battery, I should say, and it's $800 for one of those, and that's a really popular battery, and I can't afford that. You know, if I had $800 to spend on this setup, I'd probably spend it on a better inverter that draws less current, you know, less, that consumes less current on its own. And of course it would take $800 plus about another $400 or $500 to get that. But anyway, I've considered if there were some way, if Battleborn, for example, or any other lithium battery seller wanted to send me something like that to test. You can tell that I'm not a big fan. I do tinker with lithium batteries and experiment with them, and I'm knowledgeable about them, and I'm knowledgeable about lead acids. So I'm a realist, and I kind of know what I'm talking about. I've been messing with this stuff for 30 plus years. So, well, for a long time anyway. Yeah, I guess it is around 30 years or a little more. And so if any of those lithium cell sellers want to have somebody do a real test, somebody who's going to you know, maybe if they really believe in their product so much, they really believe that they're better than lead acid batteries, don't send them to somebody who is slanted. You're not going to win over lead acid battery folks that way. Send them to someone who knows about lead acid batteries and who also knows about lithium batteries. Send one to me. I'll test it thoroughly. So I have my pair of T105s over there, and they're 4 or 5 years old, 4 years old I think, and I've used them quite a bit. But I'll put those two, if somebody wants to send me one of those 100 amp hour 12 volt lithium iron phosphate batteries, I'll put it up against my pair of T105s, which comes to, when new, it came to 12 volts at 225 amp hours, 20 hour rate. So, and they're a few years old now, but I'll put those old batteries up against a brand new 100 amp 12 volt lithium iron phosphate battery if somebody wants to send me one to test. And I'll put it to a real test, and I'll tell you the real results. I'll show you the real results. I don't expect anybody will do it, but I don't care if it's a manufacturer, a seller who wants to send me one of those, or just a crowd-funded project. I don't care. I'm not going to spend my money on something I don't believe in. But if somebody wants to help me get a 100 amp hour 12 volt lithium battery or larger, I'll be glad to test it. Hey, send one big enough to compare with this. These people with the lithium batteries, put your money where your mouth is. Send me one to test, and we'll see how it fares in the shop of someone who believes in lead acid batteries and is not trying to stack the odds against them or against anything. Thanks for watching.